This conference will now be recorded.
Just give me a minute.
Hello. Hello.
Okay. Yes. I'm sorry for this. Okay. Coming back to the presentation, let's think of this slide as a regular application that a lot of people are using or we are trying to develop. Okay. These are all the parties that are involved to. Uh, I'm sorry. These are all the parties involved when trying to develop an application. That is, we do have a front end, that is, we can call it as email client. This is the example of a typical email application, right? We do have an email client, and then we have an admin, and we have an explorer where we can actually see the emails, right? And for the email to work, we have certain protocols, that is the IMAP, SMTP, and the HTTPS. And to maintain our data records and all the other things, we have to have a database. Okay, so coming to a native application, these are all the applications that are interconnected with each other, and they have to collaborate with each other all the time to make the application work effectively. So so to produce to provide a security to the application, all these things have to abide by the protocol rules that they are working with. So for a single application, that is the email client that we're talking about, all these things have to be in place, and everyone should trust each other. First thing, each and every application internally should trust each other and have to communicate in a secure way so that nobody will tamper with the data or nobody will tamper with the accounts or whatever it is. Does anybody disagree? Okay then. So this is how a regular application works. Okay, when we talk about regular applications, we have a front end UI, we have the back end architecture, which will take care of the read and writes into the database, whatever database it might be. Okay, now coming to what exactly blockchain is, a lot of people know Bitcoin, right? In 2008, Satoshi Nakamoto, as you're seeing here, it might be a person or a group of person, wanted to introduce a currency that is not centralized or controlled by anyone. With that implementation in mind, they came up with a white paper for the first digital currency known as Bitcoin. Okay, these are the people who created the first Genesis block and then implemented the blockchain database for the cryptocurrency. All right, so these are the this is the first known application of blockchain, but we cannot say that Bitcoin was based on the blockchain mechanism, because anywhere in the white paper, Satoshi did not mention that he was looking for a blockchain technology, or he was trying to create a blockchain technology. He was only trying to create a decentralized financial system where the trust between users is achieved cryptographically, and there is no need for anyone to depend on a centralized institution or a centralized person for us to move money from one place to another. That was his main intention. But later, coming on in the later years, that's around 2012 to 13, large multinational corporations looked at that technology which can be implemented also in other applications, because the blockchain, as you look at this, this is a regular example of why Satoshi Nakamoto tried to create that in the first place. This is a typical banking system. All right, it's a typical banking system wherein we have a clearing house that is a central party, and then all the other people are trying to integrate with each other with this as the centralized person or the centralized entity. Now, each and the problem with the centralized ledger, what everybody thought was that each and every person has to depend onto the central authority, and they have no other option except for relying on what the central authority says. They do not have an individual hand in trying to verify the transactions that have been made. And this clearinghouse maintains its own ledger that is not accessible to anyone. So at a given point of time, let's say these four pillars to be A, B, C, and D, each and every person will have access only to its own transactions, but cannot completely verify if the central authority is, clearly telling the truth about someone having some XYZ balance. Now coming to the distributed ledger technology that Bitcoin has implemented successfully till date. So what exactly is the distributed ledger that we're talking about? In distributed ledger, we are trying to remove the complete concept of a centralized person who's trying to control the complete architecture. So in turn, what is happening is this ledger is maintained by each and every person on the network, right? This ledger is being maintained by each and every person on the network. So what exactly happens after that? Each and every person has a complete list of transactions that the whole in which the whole network is happening. Right? Each and every person has a complete list of transactions that are happening on the complete network. And I'm sorry. And when I say that each and every person has a complete list of transactions on the entire network, people come up with questions like, if my balance is exposed to some other XYZ being, then how is it safe and secure for me? Right? For that reason, in blockchain, we have something called as unique identifiers. Those are called public keys, which we'll get into a later state. So a public key says that this account has so many money, but it doesn't reveal that who is the owner of that public key or that public address. Okay, so that's just a small example of what exactly how anonymity is maintained over the blockchain in spite of having access to all the information that is present in the blockchain. So this example that I gave is in view of the financial application that it was created on, right? But currently, as you look into the world on the different or the large implementations of blockchain, they're trying to use it in everything. And the latest news is, if you can go through in today's paper, it was the Kolkata government that has started issuing birth certificates on blockchain, right? Now, what are the properties of DLT? What does DLT mean? DLT means digital ledger technology or the distributed ledger technology. Let me explain a little bit of this term DLT. As I said, blockchain was the first protocol, or Bitcoin was the first application, okay, that was kind of implemented using the blockchain technology. It was only for payments, nothing else could be done with that. Okay, then came in Ethereum, whereas even Ethereum is a cryptocurrency, but it's a smart cryptocurrency. I would say it's smart because people were allowed to program the currency, and then uh, there are applications that were being built on top of Ethereum. Whereas coming to digital ledger but when we say again Ethereum, we are talking about currency only in the mind. So if anybody wanted to do any transaction or wanted to develop an app, he had to have that cryptocurrency with him. But a few other organizations thought there should be some blockchains that are completely independent of the currency point. These came up with the concept of distributed ledger technologies and formed together a group called as the Hyperledger Foundation. And those are the projects that we are currently looking at in the market. So people in the market right now are looking for Hyperledger Fabric or composer developers. And the next thing that is gaining more popularity is the Hyperledger Sawtooth. This is from Intel. So the projects under Hyperledger Foundation are kind of sponsored by different people. As I said, Hyperledger Sawtooth is being incubated by Intel, and similarly, we have Hyperledger Indie by the Sovereign Foundation, and so on. So, coming back to the digital lecture technology, what exactly it is? The first thing is it is distributed. As I've shown in the previous point, a network of participants that are continuously pinging each other for the information and trying to update their ledgers. Have a distributed networks that have the copy of the complete ledger and it's completely transparent. Okay, now anonymous. As I said, the identity of the participant is pseudo-anonymous. For example, we have four people: Praveen, Prasad, Vijay, and Venkatesh. Okay, we own these four accounts. At the same time, people exactly Praveen doesn't know who is Vijay in these three. He's only interacting with the. Okay, let me show you. Are you able to see this address? I'm sorry, I'm sharing a single screen. Okay. Uh, like I said, anonymity. Yeah, you can just type in Google Bitcoin address. You'll get a hexadecimal string that is of fixed length. It's called as a public key. Next, time stamped. All right. All the transactions that are happening over the network are completely time stamped. Okay. So when a transaction is for example, when a transaction is broadcasted to the network, it is timestamped by the initiator and then broadcasted, which will be inter processed with a some set of protocols for example, in cryptocurrencies that we are using, that is the Bitcoin and Ethereum, we call the protocol as proof of work, and that is in turn using some cryptographic algorithms to verify and validate the transactions, right? Next, unanimous. All the network participants, sorry, all the network participants have to agree with if the transaction is a valid transaction or not. Okay, for example, there are four people, which means three agreements. So out of four, there are three people. Three have to agree for a transaction to be valid and legit. That will be included in all the ledgers. So once the transaction is validated by some special nodes called miners, we'll get into that in detail in the coming classes. So these miners are responsible for validating the transactions and then pushing it back to the ledgers. Okay, immutable. As I said, once a record that has been entered into the ledger cannot be reversed. It's not cannot, we can. Okay, for example, A and B. A has sent $5 to B, but A again wants to cancel the transaction. He can, or he can modify saying that A has sent $15 to the transaction. He can definitely do that in his ledger and update it. But to validate the transaction, he needs the complete power of 51% of the network. So at any given point of time, there is no way he can gain the uh, power that controls 51% of the network. So once a transaction or a record that is being published onto the public ledger, it cannot be tampered with. That's the this thing you're looking for. Secure. All records are individually encrypted. So You guys might have some idea about what encryption is. So encryption is nothing but a process where something like this, a plain text is taken, and with some mathematical combinations in using a key, a ciphertext is created which is not readable to the human eye nor the computer unless and until we provide it with the same key to decrypt the data, right? And the last thing is programmable. As I said, blockchain was the initial thing that was created only for the whole and solely for the cash, for the transaction, financial transaction purposes, whereas Ethereum, that was given later. Even then, people used it for cash only, but Ethereum is a programmable blockchain wherein people can write or develop their own applications. Some of the famous applications that right now Ethereum is building is, you people can go through Uport. It's a decentralized identity. We'll have a session on that in the coming classes too. Okay. So these are the few properties of the digital ledger technology that we're talking about. Uh, any questions so far? Anybody?
It's clear.
Okay, thank you. Right. So what exactly is happening in the blockchain? As I said, right now the blockchain technology was evolved in such a way that we are able to program them, right? So as you've seen in the first slide, that to any whatever application it might be, we have a front end, we have a back end server that's actually doing all the stuff, and we have a database. Similarly, let's say these are the individual events that are being generated by n number of devices across the globe, whatever it might be, and then these transactions are trying to be put into the blockchain. So what exactly is happening? These transactions are grouped together into a block, and these blocks pass through the miners. Okay, special nodes called as miners. So what these miners do is try to validate the transaction. They try to validate the transaction uh, through the algorithms called as proof of work, and then these transactions are inter again broadcasted over the network so that each and every party can validate the transaction and add it to its public ledger. Okay, and at the same time miners can also reject the blocks that are not correctly formed or malicious transactions. In this whole blockchain thing, you have the blockchain curriculum, you will hear a lot about hash. Anybody has an idea of what exactly a hash is? Okay, let me explain it to you. I need to change this. Just a minute. Okay. Okay. So let's see, hello world, and I'm trying to use an algorithm. These are the different algorithms that are there. Okay, and this is the thing that we generally use. Has this. So what exactly happened? For any given input, we get a fixed length and a unique output that doesn't collide with anybody. And even the slightest change in the inputs gives us a complete new string that is not comparable in no way with the previous string, right? As you can see, the string has completely changed. And to give some more interpretation to it, as I said, any length string will give you a fixed string output, as you see here. So these hashes are the building blocks of the blockchain technology. the most hyped thing, blockchain hash, blockchain hash. What exactly is it? Okay, the blockchain hash is created by the miners and then assigned to a particular block, saying that this block has been mined successfully and all the transactions inside it are validated. Okay, all the transactions inside it are validated. As I said, new block of transactions include a security hash of previous block and a block that is created. So this is a sample uh, blockchain block structure or blockchain data structure, we can say, which is nothing but the which contains the header part contains the version number, that is the protocol which the currently blockchain network is using. Nonce is nothing but a single time usage number, which we'll learn later. Okay, the previous block hash is nothing but the previous block address. If you can see in this picture, it's nothing but a linked list. As people with the programming experience might know, that in the linked list, the blocks, the links in it's like links in a chain that are coupled with each other. In case of our in case of the computing thing, or in blockchain, we can call the link as the address of the previous block. That is, the address is nothing but the previous block's hash, the timestamp as to when it was created. Next, we have something called as Merkle. This is I'm sorry. This is called as Merkle root, which in turn is nothing but the Merkle tree hash. We'll later in the coming classes we'll get a detailed list of that, and then it will contain that complete transactions list as to what all transactions has been clubbed into the block. Okay, so there are a lot of factors that comes into while creating or mining the blocks. That is the block time. uh, an Ethereum block is created like every 10 seconds, and a blockchain block, Bitcoin block is created every 1 minute. So based on the kind of mining that has been happening. But again, coming into picture, we have two different types of blockchains, that is the public and private. Since Bitcoin and Ethereum are public blockchains, they require a lot of computational power to secure the transactions and then secure the ledger. But coming into the private blockchain, you can introduce your own consensus or your own protocols that will validate the transactions and will give you the maximum output of the blockchain technology when using it at an enterprise level application, which doesn't wait for that amount of time for the transactions to happen. Okay, now, as we've seen, it's the similar thing, that is the structure of the Bitcoin block, the version, previous hash, Merkle root, timestamp, difficulty target. This thing we did not see in the previous thing. Okay, so difficulty is something that is set by the protocol anonymously and automatically for the miners to create the block. Okay, difficulty target is nothing but something set by the network, Bitcoin network, for the miners to create the next block. Next, these are some of the identifiers in the blockchain data structure. What is this? Blockchain header hash. Okay, okay. Let me show you a typical blockchain block. So this is a blockchain explorer. This is a Ethereum explorer to be in fact. Okay, and these are the list of transactions that are happening each like on the go, and these transactions will be clubbed into the block. Okay, as I said, this is the typical representation of a block in the Ethereum this thing. Okay, and there are a lot of elements that we'll discuss in the classes. As I said, this is the parent hash, that is the hash of the block. Okay, no, this is the parent hash, sorry, which is nothing but the hash of the previous block. As you can see, 8305 and this is 8304. So each and every block contains a parent hash, which is nothing but a link to the previous block. And this is the hash of the current block that has been mined successfully. All right. And gas limit and gas will start to know once we start the Ethereum part. And nonce, as I said, is a single usage random number that is very much useful in creating the blockchain hash. All right, and as you can see, it's been mined by some address. This is nothing but the address of a person on the Ethereum blockchain. Address of a person on the Ethereum blockchain. Okay, and the block height is nothing but the block number. Block height is nothing but the block number that has been created by the miner. Merkle trees, as I've shown you a hash just now. So, for example, let's say there are 500 transactions in a block. We cannot fit the complete transactions onto the block, right? So what we do is we create hashes of the transactions, and then in a tree fashion, we try to create the hashes in turn, and then the top hash is referred to as a Merkle root, and then all these hashes are stored into the blockchain. We'll get into the more details of this once we start the class. Okay, so this is a typical example of a blockchain, right? That is, the blocks are being added continuously to the end of it, and then each block contains all these things. That is the Merkle root and the blockchain hash and stuff. So I think this would be good for a brief introductory class. Coming to what we learn in the class, we'll try to mainly focus on Ethereum and Ledger, and after that it will get into the Hyperledger Fabric. All right. We will be having coding sessions. So it might be like JavaScript or Golang, which I will give some introduction about. Or for the Hyperledger Fabric, we will try to use the Java SDK. Uh, any other questions you guys have? Hello?
Hello, hello.
Yes.
Yeah,
In
we have had one doubt. Is Java is required for blockchain?
It's like, as I told you, when we talk about enterprise grade applications, we have to program it, right? So Hyperledger gives us Java SDK, Golang SDK, and Node.js SDK. You can try to write the smart contracts in any platform you want.
hello.
Hello? Yes.
Yeah, in Hyperledger,
Yes.
end to end, you can explain that certificate generations and development, any POC kind of thing, or what?
Yeah, sure, definitely. I'll see that I can give you a complete application experience, not just installing or writing it on the Hyperledger Composer. I'll give you the
Okay,
complete end-to-end of how we install the Hyperledger Composer, try to create the admin
okay.
cards, create the DNA files, deploy it on the network, and then try to create some UI so that we can access those endpoints.
So it will be developed through Go language or in JavaScript, Java or Node.js.
So the Composer thing, it will be in JavaScript, and then we'll
Okay.
move to the Golang SDK or the Java SDK.
Actually, currently I'm working on Go language, and
Okay,
this Hyperledger. I know basics and all Hyperledger.
okay.
So actually, I want to know more about in depth of Hyperledger certification generation and deployment in cloud like that.
Okay, so when you say you're working on Hyperledger, is it the Fabric version 1.3? Have
Yeah,
you
yeah.
deployed the complete?
Fabric 1.3 only. I hadn't deployed it. I have used that as
Okay,
SDK.
okay,
I know few things on certification generation in using that CryptoGen tool.
okay,
Uh, some points are
okay.
stuck there to create the certificates.
Yeah, sure. Eventually, we'll get to that point in the class. But first, we'll be concentrating on Ethereum because
Okay.
Ethereum is like the building blocks where you need to understand all the basics of the blockchain, and then only we can go to the private blockchains.
Okay.
Yeah.
Kumar,
Yes, Malika.
hello. Yeah,
Yes.
what are the basic technologies required for this? Languages and right into blockchain.
No, if you are proficient in any one language, you can pick up this thing. It's not like mandatory that you need to have these. Do you have any programming experience?
Actually, long back, 3 years back, I had been working for .NET language.
Okay, right now, what is your
Right. medieval technology, WebSphere, WebLogic. So
Okay. So if
I
you
have
have a programming experience, I'm sorry.
I have a experience on JavaScript also. Initial days.
Yeah, yeah,
Actually,
sure. That would definitely help out because the Solidity language is kind of loosely based on JavaScript, and the Hyperledger Composer that will try
okay.
to go on through uses JavaScript only for the transactions. So let's see if we have any. Okay, as you can see, we have a .js file,
Hmm.
right, which is having your pure JavaScript functions only as part of that. So in Composer, we'll see JavaScript only mostly, and then as I think Vijay asked, we'll then try to deploy this network onto the Hyperledger Fabric or try to create it from scratch on the Hyperledger Fabric. So there we'll be using Golang or Node.js SDK based on everybody's this thing.
For this all data, how it will be maintained? We need to write any queries for that.
I'm sorry.
You said database is also be there for blockchain.
No, no, no. It's like, for example, this Hyperledger Composer has its own database, HouseDB or LevelDB, whatever you want to put into, right? So
Okay.
all the transactions. Let me do something. I'll create some parchment. All right. What I did was I created a parchment, right?
Mhm.
This is stored on the internal database of it. But when you look at the transactions, what exactly is happening is even creation of participation is a transaction which is there with a transaction ID that is
Okay.
nothing but the hash and the timestamp. So all these things are maintained internally in the
Mhm.
database, in each database. Coming to your question, what we can do is we can write queries, as you can see here. We can write our own queries, query file. We can add a query file and then write our own queries and then try to query the data from the blockchain network.
Okay.
Did you get the point?
Yeah, yeah. Got it.
Yeah. Anyone else? Any other questions, please?
Yeah, 1 minute. Kumar.
Yeah.
Hello. Yeah,
Yes, yes.
actually, I want to know that what is that contents of the cover this total this training and all in Ethereum and Hyperledger. What are the topics do going to cover? And
Yeah, I think I'll send it to
any
Prasad and Prasad will forward it to you, the complete
okay,
content of the course.
any POC kind application will do it in so
Definitely, we'll try to develop a small application because without that you cannot face the interviews,
yeah
how the
help
application works and stuff.
yeah.
So we'll
So
definitely
it
try to create a small application and then deploy it.
okay. So in Ethereum also you're going to do or what?
In both the things we'll try to do based on how
Okay.
the time permits. Yeah.
Actually, we thought it is an online course. So if it is possible to an offline or what? If it
I'll
is
have to
offline,
talk
means
to,
somewhat better.
but I don't think everybody can join offline, right?
Okay, because
So,
installation to setup and all will be somewhat difficult, right?
it's like I have a detailed description of each and every step on how to do it. I'll share that with you guys. It shouldn't take
Okay,
that big deal. It shouldn't be a that big deal.
okay. So
Yes,
course the duration and
it's 45 days planned for now.
okay.
So
May I know the
based on the
timings?
requirement, we can extend it for 5 to 10.
Okay,
Yeah, the timings and stuff, I think Prasad will communicate that to you.
okay, sure. Yes, that's
Yeah. Any other questions, anybody? Okay, so let me tell you how the course is going to be. It'll be mostly 1 hour session daily. Okay. In that 1 hour, 45 minutes will be completely theory, and then During theory, if required, we'll open and show you this the implementation parts initially, at least for the 15 to 20 days, but it will be mostly theory only. And after the theory, when we come to the implementation part, we need to have access to a Linux machine, wherein I'll give you the details of what to install and stuff. And once that is done, we can just uh, try to get on the same platform. Let's see how we can work that out with Prasad. Okay, so anybody doesn't have any other questions?
Yeah, no.
Okay then, thank you everybody.
Yeah, thank you.
What about this on this
I'm sorry.
freshers will get or experience will get jobs?
Hello.
About opportunities on this.
Well, if you can see, there are a lot of opportunities right now in Bangalore, Pune, and Chennai. In Hyderabad, it's a bit low, but in US and UK, there are a lot of opportunities outside India. And coming to India, all the multinational companies as well as middle-level startups are trying to grab the blockchain talent, and the pay is also really good. You just don't need to go by my word. Just
Okay.
search in Naukri or LinkedIn. You'll only know the amount of openings that are there.
For a fresher, it is good or not? I mean,
It's really
as an
good
experience.
with a little bit.
Okay. Okay.
Look, I work for a small company. I used to work for an MNC right now, but
Mhm.
since they did not have any project 1 year back, I moved to a small MNC where I have in my team two freshers working with me who have themselves trained on blockchain, and they are really good pay for a fresher that they are getting.
Okay.
Yeah,
And what about JavaScript? Do you have any parallel session for that?
we'll see
How
what
do
we
you
can
get?
do in the class only. Okay.
Okay, thank you.
Yeah. Yeah. Anything else, anybody?
Yeah, no questions.
Okay, then. Thank you very much, everybody. Goodbye.
Yeah, thank you.
Prasad
Bye.
will contact you with further information.
Yeah, sure.
Thank you.